Hello the internet and welcome back to my channel. On the desk today I have the Focusrite 18820 again. I looked into this interface on the main channel. You can find the link down below in the description. And if you haven't watched the video, I would definitely recommend you go and watch it. Lots of things happened. The interface ended up having basically 3 faults, and one was a manufacturing defect, like a design issue with the interface. So the interface went back to Focusrite. And it was mitigated. I still don't know exactly whether it's supposed to be like this. I'm still waiting for Focusrite to come back to me. But one of the issues that I fixed, or I thought I fixed on that video, was that the interface every now and then was dying for no reason. And we explored this issue, and it turned out that the 1 volt generation was dying for no reason when the interface was powered up randomly. Now the 1 volt generation of this interface is powering the digital section here, where you got some CPUs. I think this thing has like a couple of CPUs. I guess one is the main one. I don't know exactly how it works, but we've got 2 XMOS ICs, and I guess this whole section here is the digital one dealing with USB and all the management of the interface, and should be driven by 1 volt. If 1 volt doesn't happen, obviously the interface doesn't do anything. Now we looked into that and we found that the 1 volt is generated from the 3.3 volts, and 3.3 volts comes from this area here. And when the interface was in that dead state, we found that basically 3.3 volts was actually reaching the 1 volt regulator. And then it's only an enable pin, a feedback pin for regulating itself, and then there's an output. The small IC basically has everything inside. So I could only think of reflowing the whole thing. That didn't solve the problem, so I thought it must be the IC, because 3.3 volts is coming in. The enable pin we checked and it was coming in. Feedback, yeah, that could be a problem if there's something wrong with it. I think if the feedback is like disconnected, the IC doesn't go like a full blast, it just stops. But I replaced the IC and it seemed to have worked for a while. But no, it's still happening. The thing is, it happens very randomly, and apparently, at least, the few things I've tested is, it only happens when the interface is warm. So I think today we are going to have the oscilloscope running, the microscope again. Everything looked okay with the multimeter. We need the oscilloscope because I want to see whether maybe 3.3 volts has an issue, it's unstable. Maybe the IC is trying to come up with 1 volt, but the overcurrent protection kicks in. Maybe something here in this section is getting too much current when it's powered up when it's warm, which is going to be, I would say, impossible to diagnose, but we can try. And the IC has an internal protection and it stops. Now, unfortunately, because everything is enclosed into that IC, it's not like a main controller IC on a big switch and mode power supply. It has the iSense pin, and you can probe the iSense pin, and if the iSense pin is going over 1 volt, well, you know that the whole thing stopped because there's an overcurrent or over voltage protection. That doesn't have it. It happens internally. So there's definitely not an over voltage, because I would have measured that with the multimeter. Measuring the current coming out of that very little tiny IC is going to be difficult, so I'm hoping that's not the case. Now, one thing that many of you mentioned is that the enable pin is on the low side. It's only reading 1.35 volts, if I remember right, and I think the data sheet of that IC says it has to be at least 1.2 volts, and it feels a bit like close to the threshold, and that might explain what happens. But actually, I have the drawings, the drawings for the Scarlett Solo are available, and it's the same exact IC, it's the same exact configuration, and I can see that the enable pin is derived from 3.3 volts through a voltage divider, and if I do the math on the schematics with the voltage divider, it turns out to be 1.3 volts. So no, I'm expecting 1.3 volts by design, so that should be fine. We haven't got many options, but one thing I definitely want to do today, which I didn't do on my last video, is to replace those cracked resistors which are part of the feedback circuit. Now, I'm not certain that I cracked them with my tweezers. I have a feeling that those were cracked already internally, and by reflowing them, so applying heat, those are very little components. So when you apply heat, you're basically taking the whole component at 200 degrees in an instant. So by applying heat and touching them with the tweezers, the crack just came out, let's put it that way. Now, why that would only affect the feedback circuit when you're restarting, it's kind of a mystery to me. But the point is, you have cracked components, so we need to start and replace those components anyways. I just didn't want to get some components from AliExpress on a feedback circuit for a pretty important voltage generation. So I got some components here from DG Key, hopefully which I can trust. They're 1% SMD components. They're really small. These are the 0603, so they're really small, but those definitely need to be replaced. But I would say first thing first, I want to turn on the oscilloscope and see how the circuit works when everything works. Do we see anything wrong with the 3.3 volts? Do we see anything wrong with the enable pin? Do we see anything wrong with the output? Because the thing is, when the interface works, it works. It never stopped working on me for no reason. It never crashed. It never restarted. It never powered off, because the symptom of the 1 volt missing is just that the digital section dies. It never died on me while it was working. If it works, it works. If it doesn't power up, it doesn't power up. When it powers up, it stays up. So that's pretty weird. I would say let's turn on the oscilloscope and let's start poking around and see how the circuit works when it's working. Okay, I got the oscilloscope running, and I got what Adrian would call improper grounding here. So the ground lead, it's extended, and that's never a good thing, because you get all sort of interferences, especially because there's a switch in mode power supply here, so you might get some noise, but hopefully that's not gonna affect our measurements too much, but it's something that we wanna keep in mind. Now, first thing first, let's check the 1 volt. I've no idea whether this is gonna work right now. I haven't turned it on intentionally, and I've got my probe on the 1 volt, and I've got 500 millivolts per division on the oscilloscope. So, let's see what we see, and we'll move from there. So let's turn it on. 3, 2, 1, go. Okay, well, that seemed like a very clear 1 volt, and obviously the interface is working, at least the 1 volt is working. It's reading 1.01, and I would say it looks fine. Again, that little noise that you see is probably caused by the ground lead, assuming you can see that on VNC. This is the 1 volt in AC coupling, so I got the resolution at 50 millivolts, and all those spikes, I'm pretty confident it's going to be my setup here, my ground lead. Again, if I'm touching the ground lead and stuff, you see all sort of noise going in. That's unfortunate when you are doing these measurements, but the main voltage seems to be fine. Now, what I'd like to see is at some point, maybe now or when it refuses to start, is it starting like clean, or is it struggling to start maybe, and we see something. So I might need to set the oscilloscope in single mode and see what happens. But let's move on and let's check the 3.3 volts first. This is our 3.3 volts. It looks fine, I would say. It's reading 3.3 volts. And there's, nothing horrible. I'm sure if I'm zooming in, I will see the same noise that I was seeing before. Let's turn these off. Let's give it a few seconds and turn it back on and see how it turns on. Whether it's like instant or maybe there's some uncertainty or whatever. 3, 2, 1, go. Nope. I'm not sure how much this translates on VNC. VNC is a bit on the slow side, but I'm looking at the oscilloscope, and at least what I could see, it was just going up straight away, and 1 volt is working right now. Now, next I'm going to check the enable pin, and again, we'll see how quickly it goes up and how it looks on the scope. 3, 2, 1, go. That looks fine to me, and this is still working. So far, I would say so good. I don't see anything weird. Now I got the oscilloscope set to single capture, so it will stop whenever the enable pin is going over 1 volt of some sort. So hopefully we can take a look. 3, 2, 1, go. That's some noise. That happens, and unfortunately it's triggering the single capture before the 1 volt, the enable pin is actually going up. Let's try this again. I've just increased the time per division. 3, 2, 1, go. Nope. Unfortunately, I have that noise spike, and I don't know how to tell the oscilloscope to just ignore that one. Try again with a longer time base. 3, 2, 1, go. Let's try again in roll mode. It might give us an idea. 3, 2, 1, go. Okay. And as you can see on screen, it looks totally fine to me. There's no uncertainty. It just goes up more or less straight away within like 10 milliseconds, so that looks fine. Let's try and do the same with the 3.3 volts and then with the 1 volt. Let's check 1 volt first. 3, 2, 1, go. We are losing a little bit of resolution by zooming in this way, but I don't know, it looks fine. Again, I don't see any uncertainty or anything that might, cause some concern. But obviously we'll need to check when it's not working. Right now the interface is working. Let's check 3.3 volts. 3, 2, 1, go. Well, on 3.3 volts, I can see a little uncertainty, something that happens. But again, I wouldn't think that could be a cause of a problem, to be honest. But, let's keep in mind that the 3.3 is the only voltage which is having that little uncertainty at some point. Honestly, I think it's nothing, but I think, next is going to be, let's reproduce the issue. I think I'll warm up the whole thing and hopefully at some point it will happen. And then we'll check again while the interface is not working. Alright, I warmed up the interface and yes, now it's in that weird situation where there's no 1 volt. So let's check what we get out of 1 volt. Maybe there's something that is trying to happen. And no, there's absolutely nothing happening. I've got 500 millivolts per division. There's no, the IC is not trying to power on. Sorry for the interruption. I made a mistake here. I said there was no 1 volt, but there is. It's there in front of me. I think I got confused by the trigger icon on the right, which happened to be perfectly aligned with the 1 volt line, but no, 1 volt was there and was totally fine. I will mention the missing 1 volt a few times further on in the video, so sorry for the confusion. However, 1 volt was 100% missing in the previous video. I have video evidence of that. We do. So we do have the 3.3 volts, but we don't have the 1 volts out. So yes, we definitely fixed that, but apparently that wasn't what was causing the interface to misbehave. Weird. Let's check 3.3 volts. And 3.3 volts is normal. Again, it's not unstable or anything, so there's no output. There is input. At least I'm checking on this via. I'm checking on that IC, especially on camera, is going to be pretty difficult. So I'm kind of assuming that is not a problem. Let's check the enable pin. What is it doing? Is it stable? Is it going up and down? And here is the enable pin. It's reading 1.32 and it's totally stable. So I don't understand. Everything seems to be working. It should work. Now the next thing I want to try is, assuming this happens again, but hopefully by warming up the whole interface and not just that area there, I want to see what happens to the 1 volt when this happens, when I switch it on and it doesn't turn on. When it comes to audio project, PCBWay has a whole audio section on their shared project webpage where you can browse and order PCBs directly. If you find something online that you like, well, all you need is the Gerber file, upload it on PCBWay.com, the process is automatic and PCBWay will deliver the PCBs at your place. If you follow my channel, you know that I've been using PCBWay for quite some time. I cannot complain about the quality of the PCBs, and the customer service, honestly, is top-notch. The 8th project design contest is on at PCBWay. Anybody can participate. If you have a cool project, whether electronic, mechanical, or one that combines AI, IoT, and embedded systems, well, take a look at PCBWay.com. You can submit your project until the end of January 2026, and an independent panelist will choose the winners. All participants will receive 600 points, equivalent to a Raspberry Pi Pico 2. Take a look at PCBWay.com, the link is also down below in the description. Let me thank PCBWay for sponsoring my videos, my channels. Their help makes these videos possible. Now let's continue with this Focusrite. Alright, plot twist. I put my probe on the 1 volt, basically ready to see what was happening when I switch it off and on. And now we have 1 volt, but the interface is not running. I'm assuming that 1 volt started running at some point, but maybe there's some timing which is required for the CPU to reset, and once that time is gone, the interface the CPU won't reset if the 1 volt is coming back, but it has come back. It was definitely at 0 earlier on, I think. I need to double check the footage. But now we have 1 volt and the interface is dead, and I'm assuming if I'm switching it off and back on, it will work. 3, 2, 1, go. Yeah, it's working. Okay, so if I'm right, I'll switch it off again, I'll warm it up, I'll make the 1 volt disappear, and then I'll keep testing, and at some point we should see the 1 volt coming back up, even though the interface is not going to start, probably because of some timing issues. Oh, all right, so the interface now is not working, but we have 1 volt. Oh gosh, this has got worse. This has got worse. What's happening now? I didn't realize that. Something is going on. I think I also see the 1 volt going up straight away. I think it was like there was a small delay earlier on, but I might be mistaken. But now I got 1 volt, but there's no activity here at the front panel. Oh my. There's something that... So how could that be related that earlier on, when the interface was not working, we didn't have 1 volt? But now we have 1 volt and the interface still doesn't work. That's pretty weird. I can't find the logic in this. I can't find the connection in this. Now it's working. Now it's working, but... Oh my, this is complicated. So now I don't know what to check anymore, because obviously now it's not a voltage issue. We still have an issue, but it's not a voltage issue. But it clearly responds to hot air and cold spray. Well, at least to hot air. So I guess maybe if I fiddle around this area with my hot air station, I might find what's wrong with it. Now again, we have 1 volt, but the interface is not working. So it's 100% responding to heat. But now we have the voltage. And it's definitely... Oh gosh. Now this is getting... I'm very confused because now it's not a voltage issue, but we still have an issue. Okay, well, I might have identified where the problem is. Well, number one, now the 1 volt seems to be working every time. I honestly don't understand. The 1 volt generation is completely independent, so maybe the overcurrent is a possibility. There's something here causing an overcurrent and the 1 volt stops, and that's why earlier on we saw it starting again. But unfortunately, it looks like if I'm warming up this area here, this little IC, which is one of the CPUs, I'll have a look in a minute, it stops working with the 1 volt still running, which is new. And when I'm cooling it down, just that IC, or maybe the surrounding, I'm not sure about that, it starts again every single time. So I found my little trigger that I was looking into my other video and I couldn't find, but now, yeah, it's this area here. And unfortunately, this IC is a weird package. I don't think it's BGA, but it's not one of the legged ICs, and you know, it means that basically it needs to be reflowed, which honestly I don't want to do. I need to have a look at how that works. I might be able to access the contacts from the sides. But yeah, that's weird. Or it's broken inside, as sometimes happens with those things. It's just there's some broken traces inside and they just connect and disconnect with heat. So let me move everything under the microscope because I need to inspect that area very carefully, look for some cracked components or anything. I know that we have some cracked components here in the 1 volt, but at this point, 1 volt doesn't seem to be the problem. So yes, we're going to replace them anyways, but that doesn't seem to be the problem. So I want to have a very close look around this XMOS processor. With the current symptoms, it would make sense to check the clock and the reset line, which is not easy because unfortunately everything is under the CPU. It's not really accessible from anywhere, I think. But when it comes to the reset line, I think it's generated by this IC here. This is getting, I think, 3.3 volts as a power supply, but it's monitoring the 1 volt line, which is this line here. And when the 1 volt line comes up online, it's basically an active low reset line. So I think this via here is 3.3 volts. So it's pulling high the reset line. The IC is just making sure that the the reset line stays low until the 1 volt comes up. So first thing first, let's make sure that we have 3.3 volts on this via here, and then we'll check what the reset line, I think that via goes to the reset line on the CPU. We'll check what it does. 3, 2, 1, go. So yeah, that is the 3.3 volts line. The interface is working, by the way. So let's turn it off again and check what I think is the reset line. And we don't see much because I think what happens is that the 1 volt is coming up basically immediately after the 3.3 volts. So the role of the IC is just to keep the reset line at 0 volt, a tiny little amount extra time, until the 1 volt is up and running. So you see exactly the same waveform. If we compare the 3.3 volts with the reset line, we would see that the reset line goes back up to 3.3 volts a bit later. Now, what I want to try is to trigger that non-working situation and see if by any chance the reset line never goes up to 3.3 volts. And that would, point to a different issue. So I don't understand how it could be related to the 1 volt missing, but I don't know. Right now we have the 1 volt, but the CPU is not working, so and it's intermittent. So this is a nightmare. But anyways, let me trigger the issue again, and then we'll check the reset line and we'll see what it does. 3, 2, 1, go. Okay, no, the interface is not working, and the reset line, I would say it is working because it went up to 3.3. So it means that the reset is not active. Let's try this again. 3, 2, 1, go. Yeah, interface is still not working, but the reset line is working. Yeah, so it's not a reset line problem. That being said, I'm measuring there. I'm not measuring under the CPU. It's impossible to do it, unfortunately. So, well, that's telling us that the reset line is working at least where the IC is. I'm now checking the crystal, which is close to the CPU. It has 26 written on top, and it's reading 26 megahertz, so that is fine. That being said, I don't know, I'm assuming that if I reset the interface now, it's gonna start. 3, 2, 1, go. Yes. So what I want to try is to trigger the problem and check that the clock is actually working when it happens, when the issue happens. Because what might happen is that the clock is missing, the reset line is resetting the CPU when the clock is not there, and when the clock is back, it is waiting for a reset line, which has happened already. So let me try and re-trigger this thing. Well, at least I have a way to trigger it now, and we'll check the clock again at the IC. Unfortunately, I can't check the clock at the CPU because it's under the CPU itself. And the interface is in that dead state, and we do have the clock, unfortunately. So it doesn't seem to be a clock, again, assuming it's reaching the bottom of the CPU. I might have discovered something, and I might have discovered something, and I got my iPhone so you can see when this interface is working or not. I found that if I cool down this area here, the interface stops working. And if I cool it down, it starts working again. That's a bit further away from the CPU. Obviously, when you are cooling down and warming up things, it goes a bit of everywhere. But that seems to be like every single time. Well, the CPU, sometimes I have to spray twice, which makes me think maybe it's not that CPU, it's something adjacent to the CPU, because if there's an issue within the CPU, just a little squirt of cold spray should be enough to trigger the problem. Let me see if I can show you. Now, I've got the hot air running at 11. It's really, really low. And I'm going to warm this area up. Okay, is it working now? It is still working. Okay, so let's warm it up a bit more. I mean, the air is really, really low. So maybe that's why. Try this again. And it's not working. Perfect. Now I'll turn this off and spray cold spray just there, more or less. Okay, let's try, and it's working. Wow, it's been very precise. It's happening every single time, where previously, I had to insist with hot air and cold spray, which usually means I'm not in the right spot. Warming this up again. Try again. Dead. Perfect. And cold spray. I got the microscope in the middle, but let's try if that's enough. and it's working. Okay, I have no idea what that is. If I'm seeing right, I think it's getting 1 volt and it's doing something. I absolutely have no idea. But let me inspect that really close. Look for some cracks or anything, and maybe I want to reflow that bit. Maybe that is our problem. The thing is, again, I have no idea what that is doing, and I think it's more or less impossible to find out what it's doing. Well, I don't see anything on these components, but I'll go ahead and reflow those bits, and maybe that is making a difference. Well, no, that didn't help. However, I've been poking around. There's definitely something in that area. I got the hot test station at minimum. Literally, I mean, I can barely feel it. So I'm not warming up areas which are too far away. Though, obviously, when you're warming up any area of a PCB, the PCB will slightly warp a bit, and which means it might affect something which is further away. That being said, now it looks like if I'm warming up that resistor, or at least this area here, R219, I can easily trigger the it's working, it's not working. And once again, 1 volt now is working totally fine. So I have no idea. Well, that's the reset generation. So if that doesn't work, obviously the CPU won't start even with 1 volt. So that would make very much sense. So let me show you again. Let's try now. So now the interface is working fine. And I'm going to warm up that area only. Okay, try again. No, it's still working. After a while, when I'm on that area, it stops working, but that could be something adjacent because obviously I'm warming up something. I'm warming up an area here and the heat will go everywhere. There it is. Now it's not working. And if I cool, it's difficult also because I have the microscope in the middle, in the way. Goes a bit everywhere, but if I try now, it's working straight away. So it's something there. I'd be tempted to remove the board and have a look at the backside. I'm assuming this is a dual layer. It's not like multiple layers. And maybe there's something at the back that I can see, but I think the next step would be to reflow this area. I'm a bit shooting in the dark. I could try and check the reset line, whether the reset line is actually working, but I need 2 channels on the oscilloscope. I compare it with the 3.3 volts and the reset line, and then I'm expecting the reset line to release the reset line a bit after the 3.3 volts comes up, or the 1 volt actually in this case. But I think I'd like to reflow things. It's a possibility that the heat is reaching the CPU as well. It's not too far away, as you can see, but I'm being very careful. I'd be kind of surprised that it's something with the CPU, with the BGA or something related to the CPU. It looks like it's more something in that area, but I'm not entirely sure. Before I reflow anything, I've got my 3 probes and I've got my oscilloscope running. I want to check that reset line. I'm curious to see what it does, and most importantly, whether there's any difference between the working state, non-working state. So what you see on screen, you have 3 lines. The purple line is the 3.3 volts line. The yellow line is the 1 volt line, which is generated by the 3.3, so it will start after the 3.3 goes up. And the cyan line is the reset line. I'm not entirely sure what to expect, but it's going to be something after the 1 volt line has gone up and running, because the role of that reset IC is to wait for the input, which is in this case is the 1 volt line, wait for a determined amount of time. I think it's determined by some components, and then do something to the reset line, basically reset the CPU. I'm not entirely sure whether we're gonna see just the line going high or maybe pulsing it for a moment. We'll check in a minute. So hopefully I haven't done anything wrong here. Let's turn it on. 3, 2, 1, go. Okay, and this is not working. I guess I'll have to set a single capture and see exactly what happens, because everything happens pretty quickly here. So this is what I'm seeing. I'm seeing that 3.3 volts is going up. 1 volt actually starts even before the 3.3 volts is completely up and running. And the reset line, I think it's pulsing very quickly as soon as 1 volt is up and running. I was kind of expecting a little bit more time between the reset line pulsing and the 1 volt up and running. You know, this seems to be pretty rushed up, if you allow me to say that. You know, I would expect 3.3 1 volt to be very fully up and running before the CPU is reset, but it's definitely working. The interface was starting up when I tested this, and there is a pulse of the reset line. Even though, again, it's while the reset line is going up, it feels like the delay is not enough. Maybe that could be our issue. I have no idea. But let me see if I can trigger our issue and see if we get anything different whatsoever. Let's see if we get the same pulse in the same place. And now it looks identical. That's the same pulse in the same moment when even 3.3 volts is not up and running, but I don't see any difference and the interface refused to start. So I don't know, I'll go ahead and reflow the area and also replace those two feedback resistors. As I said, I still don't understand why now we are not chasing the faulty 1 volt, but we still have the same problem. That's honestly a mystery. The only thing I can think of is the reset circuitry, which seems to be working, by the way, or at least it works as before, is using 1 volt. So maybe there's something there upsetting the 1 volt line. Honestly, I don't know. This doesn't make any sense whatsoever. And unfortunately, my troubleshooting is limited because the CPU pads are not accessible. So what I can do now is reflow everything, because I can definitely trigger the fault with hot air every single time. It's become pretty obvious. So let's reflow everything. Let's also replace those two resistors, and then we'll test again. No, that didn't help, unfortunately. And I inspected all those components, I can't see anything wrong, I checked all the traces, all the vias. Obviously, because it's intermittent, it only happens when there's some heat applied. It's kind of pointless to check with the multimeter, because obviously the multimeter will work. This is definitely some kind of either a mechanical problem or something inside an IC. And then I basically applied heat in that specific area while I was holding my finger on the CPU. And quite surprisingly, the CPU was getting warm, actually pretty hot, pretty quickly. And then I realized that, when you have like through-hole components, you can warm up a capacitor, and probably the surrounding components are going to be unaffected or mildly affected. But when it comes to SMD stuff, well, you got an SMD components which is attached to the board, and you got traces everywhere, and we have a CPU there. So we got traces going around, departing from the CPU everywhere. At this level, at other layers at the bottom. The bottom line is those traces act as heat pipes, like on GPUs, CPU coolers and that kind of stuff. I never really thought about that, and that makes the whole technique much less accurate, because obviously when I'm warming up that area, the heat is going everywhere and it's being transmitted everywhere via the traces themselves, via the power planes and ground planes and that kind of stuff. So honestly, at this point, I think that the problem is with either the CPU or the BGA under the CPU. Now, I think I haven't checked. I think those CPUs might be available on the market somewhere. The thing is, that's BGA. I'm not very good at BGA. There's tons of small components around it, so I don't feel comfortable removing or even reflowing that IC. My main concern is that the PCB might get damaged. It might popcorn. It's September here. It's been raining a lot. It's very humid, even though I have dehumidifiers and everything. But we're not in Texas, and I have unfortunately bad experience with BGA when the PCB damages itself. I don't care about the IC, assuming I can find another one. But if the PCB bubbles up, delaminates, popcorns, whatever you want to call it, well, that's the end of the line for the whole interface. This interface is working. I'm using it, and a brand new one is more than £300. So I don't think I'm willing to go that direction at this moment. If one day this stops working, well, at that point, there's nothing to lose. But right now, this is kind of working. Now, before I completely give up, I still would like to have a look at the bottom, at the back of the CD or the PCB, and see if by any chance I can see something. I might try and reflow, maybe some vias, check some traces. I don't know. I think it's worth to take a look at the back of the board, and I'm not entirely sure whether this board is only double layer, or maybe there's some layers in between, which would make everything even much more complicated. I think we are getting to the end of the line anyways, at least for what I want to do here today. But let me remove the PCB and we'll take a look together at the back. This is the back of the PCB. These 5 vias are the ones directly behind the CPU, and you can see a little bit of reworking that I've done from the other side. Obviously the solder has penetrated and through the vias on this side here. Now, one thing I don't want to do, I don't want to reflow the vias which end up behind the CPU, because you might end up with something like this, especially like this one. There's a little bit of extra solder seeping through the via, and what happened is it could short something behind the CPU. So I'm gonna leave in place this area here, which might be important, but there's no, I don't want to risk it from this side. I'm going to inspect real close all those traces, but I don't see anything nasty here. Again, there's a little bit of dirt. I'll give it a clean. I don't think that we have a problem here, unfortunately, and using a flashlight I can see that this is definitely a multi-layer PCB. I can see the stuff inside. There is definitely a big ground plane here, probably to isolate the CPU from interferences, or maybe to stop digital noise from going somewhere else. But anyways, I'll give it a good check with the oscilloscope, with the microscope at maximum magnification. I don't see a problem here, unfortunately. I don't see anything obvious. There's no corrosion whatsoever. So let's take a look, but I'm not expecting much. I had already recorded the outro of the video, basically saying nothing I want to do on this interface because it requires BGA, so thank you for watching, see you next time. Then I stumbled on the oscilloscope screenshot where you see the 1 volt going up and the reset line happening, and I've noticed something. Now the first voltage generated from 5 volts is 3.3, and then 3.3 supplies 1 volt, and 1 volt then supplies the reset IC. The reset IC basically pushes the reset button as soon as the 1 volt is up and running. But if you look at the oscilloscope, you can see that the 1 volt is going up pretty quickly. And if you check on the datasheet, it's telling you how long that IC, that regulator, would take to go from 0 to the required voltage, and it's matching the datasheet. But if you look into the 3.3 volts, it's going up pretty slowly. It takes several milliseconds, if I remember right. If you look at the datasheet, it's giving a much smaller number, so it sounds like maybe there's an issue with the 3.3 volts. I mean, it takes so long, to the point where the reset happens when the 3.3 volts line is still going up. And I'm wondering, what if this strange non-working state, which happens when I'm warming up the circuitry, happens not because there's something wrong with the CPU or anything, but maybe the reset line happens borderline, because 3.3 volts is still not up and running, and under normal circumstances, normal temperature, that's fine. With a higher temperature, I'm just changing some internal components, characteristics, parameters, and that what used to be borderline is not good anymore, and that's when I need to cool it down to make it happen, to make it work again. If you look at the oscilloscope, you also see that the 3.3 volts is sagging a bit. I think it's when the 1 volt is going up or the reset line happens, but you wouldn't expect that. And anyways, it should happen, 3.3 volts should be very much up and running when reset happens. And if I understand correctly, those two CPUs, they're using 1 volt for the core voltage, but they use 3.3 volts for the IOs. So, it's kind of an important voltage, let's put it that way. And without schematics, it's difficult to try and ascertain what the problem is, and obviously you've got quite a few components on the 3.3 volts. Obviously there is a big capacitor on the 3.3 volts line, so maybe that is the problem. Maybe it's just damaged enough or faulty enough to compromise the 3.3 volts line a bit. I can check that at some point, but before I'm going into chasing ghosts with the 3.3 volts line, I'd like to do a test. What I'd like to do is to manually reset the interface while it's in a non-working state and see if by any chance it's gonna start again. So I'm gonna warm up those components, make sure the interface is not starting, then I'll manually basically push the reset button and see whether the interface starts immediately. If it starts and it's consistent and it starts every time I'm simulating this scenario, well, then it could be that either the reset line basically the reset button is pushed too early every time I'm switching it on, or maybe there is a problem with the 3.3 volts and the reset line happens too early, so maybe I need to look at the 3.3 volts. Now, before I do that, I need to understand how the reset line works, and without schematics it's a bit complicated, but I've done a little bit of off-camera work and I'd like to show you what happened, because the first thing I'd like to do is to try this reset mechanism when the interface is working to confirm that the reset line happens and the interface actually resets and works normally when everything is working as expected. The reset signal comes from this IC here. This IC here is sensing for the 1 volt, and when 1 volt comes up and running, I think it's over 0.9 volts, it waits for a number of microseconds or something, which I think is configurable with some components, and then pulls down this line here, which is a 3.3 volts line. 3.3 comes from here through a resistor which is behind the wire you can't see, and basically pulls down that line, which happens to be the reset line for this IC here. The reset line is active low, so it's being reset when it's low. Now the interface has two CPUs, so there's another one here, and I was trying to understand, what happens if I reset the yellow wire? Am I only resetting one ICs? What happened to the other one? Is it gonna work? Is it gonna go in a kind of an illegal state where I've reset half of the interface? So I looked at the datasheet and I found that the reset pin is this one that I marked with green, and I found it coming back here on this via here, so it was a bit easier to probe. And from here, as you can imagine, it took quite some time. You'll have to trust me because I haven't got a lens wide enough to show you this, but if I'm checking that reset line, the reset via that I showed you, it comes back here. So if you look here carefully, the reset line is this pin here. As you can see, there's a trace going up here, and it comes to this IC here. It said Z07D. I looked online, this is a buffer. So basically we have the reset line going into these pins here, and it comes out exactly as it is on the other side. It's just buffering it. So whatever comes in, comes out. So on one end, we have an LED, which I tested it. I never see that switched on, but it happens for so little. I think that's for diagnostic in case the reset line gets stuck for whatever reason. I don't know why there is an LED there. But most importantly, you can see that this pin here, which is the reset line coming from the main IC, it follows this trace and it comes to these component here, and it's basically connected to the green wire. So the bottom line is that when this IC is pulling down the reset to reset the first CPU, the same reset signal goes to the other CPU as well. And I'm assuming it goes somewhere else because there's also another via here. You can't see it's behind the wire. It's probably resetting something else. But the bottom line, I think, without schematics, it's impossible to be certain. But I think that if I pull down this yellow wire, I'm automatically resetting the whole interface, because I think that's the only point where the reset line is controlled. So by resetting that line, I'm resetting everything. So what I'm going to do, I'm going to turn on the interface, make sure that everything works, and then I'm going to touch the yellow wire, which is connected to the main reset line, with this, which is basically a 10K resistor connected to ground. So I'm grounding, pulling down actually, the reset line via a 10K resistor. I'm going to monitor that on the oscilloscope, so to make sure that the reset line actually goes to 0, and I would expect to see something happening like probably all the lights at the front panel, they would switch off and then back on again. Maybe I can plug my computer and make sure that the interface disappears and appears again. That kind of stuff. And if that works, then I know that my little analysis of the reset line is working, and then we'll try and simulate the non-working state, and we'll see that whether that makes a difference, resets the interface and the interface starts working. Alright, I'm ready to start on the oscilloscope. The yellow line is the 1 volt line, the purple line is the main reset line coming from the reset IC, and the blue line, cyan line, is the reset line after the buffer, so for the other CPU. So in theory, I should see the 1 volt going up and the reset line of both purple and cyan line basically happening more or less at the same time, and bringing the 3.3 volts line down to 0 momentarily. So I'll fiddle with the oscilloscope a bit to make sure that we have a clear single reading, so then we can test when we are doing our manual test. First thing first, let's make sure that everything works. 3, 2, 1, go. Okay, interface has started, and yes, I see a 1 volt. I see the 3.3 volts on the main reset line and the 3.3 volts on the other line. Let me set a single capture on the scope so we can stop it. It's a bit difficult to trigger the oscilloscope because there's some noise happening as soon as I flip the switch, which is obviously triggering the oscilloscope and everything. But anyways, you can clearly see that the 1 volt line is going up pretty much instantaneously, but the reset happens when the 3.3 volts line, because the reset lines are using 3.3 volts, is not yet up to 3.3 volts. So that's kind of weird. But anyways, let's see what happens. Let's not get to the 3.3 volt yet. What I'd like to do now is to reset the interface. So I'll set the oscilloscope for single capture. I'm gonna reset it manually using my my little resistor here, and I'm expecting I don't know, either I'm burning everything, which is a possibility. I'm expecting to see the 3.3 volts, the reset line to go down a moment, and maybe here the locked LED and the power LED to just disappear for a moment. Let's try that. Resetting in 3, 2, 1, go. Yeah, I could see the locked disappeared, and oh, we have quite a lot of noise, of course, and that's me, and it's difficult to trigger with this noise, but it did work, it did reset. Let me see if I can get a better capture of the waveform. It's probably easier to see that in a roll mode, so I'm trying to reset in 3, 2, 1, go. Yes, you can see it's going down, and I'm hoping, I wasn't looking, but I'm hoping that that has reset. Let me try while I'm looking at the actual interface. 3, 2, 1, go. Yes. Yes, so that works, and the interface seems to be, you know, resetting totally fine. So now let me get my hot test station, let me put the interface in that weird mode, and then afterwards I'll try to reset it and see if it starts straight away, or if it refuses to start and then it points at probably something else. Okay, interface is in that weird mode. Let's reset it now. 3, 2, 1, go. The interface has started. Let's try this again. Okay, interface, it's again in the limbo. Reset, 3, 2, 1, go. And it has started. Okay, it's just I'm not doing a very good clean contact. Let me apply a switch to the reset thing. Right, I have applied a switch to my little contraption here to make the reset pulse a bit cleaner than before. So let me put the interface in the limbo state again. Okay, this is it. So let's reset now. No. Again. No. It needs to cool down, and eventually, there it is. And now it started. Even though it says USB active, it shouldn't say USB active. I didn't like it. Okay. So no, the interface misbehaved for quite some time. I was quite scared, but now it seems to be working. I haven't plugged it into a computer, but now it's actually starting. So no, it looks like my theory is incorrect. It can't be the 3.3 volts at that point, because by resetting when 3.3 volts is completely up and running, I'm removing that from the equation. So it could be something else. Obviously, it could be that when I'm resetting the interface, there's something else happening at the same time, which I'm not triggering with a manual reset. It could be a number of things. Without schematics and knowing exactly how the interface works, it's incredibly difficult. So no, unfortunately, my theory is not working, and it's kind of sad because I was kind of sure that has something to do with that. I could definitely revive the interface by manually resetting it, but who knows what's going on. Now, still, that 3.3 volts is kind of weird, so I think I still would like to maybe try and replace the capacitor which are on the 3.3 volts line, and I think, you can't really see this, but I think I've identified at least one that is on the 3.3 volts line. I'm not sure whether there are more, but I would need to remove the board, check at the back, and buzz the lines with my multimeter, find all the capacitors on the 3.3 volts line, and maybe remove one and test it with my little component tester and see whether that could be an explanation. I have no idea. I doubt it, but you never know. My manual reset technique might be faulty, as in maybe that's not how the whole interface resets. So maybe there's nothing I can do to recreate the actual reset that happens when I'm turning on the interface. And maybe the 3.3 volts line is the problem. I don't know. I just would like to take a look. I've gone so far. Let's check that one too, and let's see what happens. Right, I might have another plot twist. I don't know. As I said before, I've now learned that when I'm warming up and cooling down parts on an SMD populated board, PCB, unfortunately the heat is going everywhere. But now I think I found a spot on the board where if I apply heat, it stops working immediately when I'm power cycling it. And when I'm applying cold, it starts working immediately. You might have noticed that when I was doing that around the CPU, it was taking a little bit of time. It was never immediate. And you'd expect that if the fault is there, it doesn't take much heat to just cause it. And the spot is that one. That, ladies and gentlemen, is the 3.3 volts generator. I started working with the capacitor first in case it changed something, but then I realized that if I'm warming up the 3.3 volts generator, it stops immediately when I'm power cycling it, and if I'm cooling it down, it starts working immediately. Let me see if I can show you this time. So right now, the interface is working, you can see that. I'm gonna warm it up. The airflow is kind of low, 250 degrees. I'm gonna warm up just the IC here. Give it a second, turn it on, dead. I mean, that can't reach the CPU in just a few seconds. There's no way. The CPU is like 10 centimeters away. I'm gonna cool it down. Okay, let's see if that's enough. 3, 2, 1, go. On. Let's do this again. I'm warming up the component here. Okay, let's give it a second. 3, 2, 1, go. Dead. And let's give it a sec. Let's cool it down again. That might be enough, might be not. 3, 2, 1, go. And it works. I mean, I've been doing that for several minutes and it's doing that every single time. So now I appreciate that I see it's on a big ground plane and that the heat is going everywhere, but I'm literally applying the heat for like 3 seconds. While previously it would take some time. And now I'm wondering whether either one of those legs has a soldering problem, which can happen. If you remember my monitor, I'm looking at that monitor, it's still working. The monitor I fixed in this video is still working, though I couldn't find anything on that regulator. There was definitely a fault with the soldering. Or it's faulty, or it's the adjacent capacitor. So the first thing, let's reflow everything around there. And if that still doesn't work, we'll replace those 2 capacitors. If that still doesn't work, I'll go ahead and order an IC, a 3.3 volts regulator. That's an adjustable one, but another one of those regulators. And no, the issue is still happening. Let me go ahead and swap all the capacitors that I can find on the 3.3 volts line. At least if I was able to remove that little sagging of 3.3 volts, you never know, that could be, I don't know, helping with this issue. I have no idea. On the 3.3 volts line, I see this 22 microfarad capacitor, which I have replaced already earlier on when I was dealing with the 1 volt generation. I thought I'll just replace it. And then I see these 2 big green capacitors, and I can confirm that from the back here. This is my 3.3 volts test point, and I have this capacitor here and this capacitor here. So let me go ahead and replace those 2 capacitors, plus I'll replace this very small capacitor which is just nearby the 3.3 volts regulator. I'm not entirely sure what the role of it is, and then we'll move from there as usual. All right, let's check these capacitors. I've got these two 220 microfarad 50 volts from Capscon. Not sure why 50 volts, it's a 3.3 volts line. And these very small 10 microfarad 16 volts, which I think is part of the regulator, is doing something. So I'm testing at 100 hertz at the moment. So let's check this capacitor, and it's reading... Well, it's reading 206 microfarad and 247 milliohms, which I think is totally fine for a capacitor like that. So unfortunately, this seems to be fine. Then obviously, you never know. It could be that these capacitors are misbehaving on the inner circuit. This one, which is identical, it's the same reading, 206 microfarad and 255 milliohms. So yeah, not great luck here. Now let's test these 10 microfarad. Now this is reading 8.7 microfarad, but it's reading 25 ohms of ESR, and this is the frequency 100 ohms, which I understand is where you maximize the ESR. Let's put it away. So the ESR is bad at 100 hertz, no ohms. It's actually skyrockets. I can change this to like 10k. At 10k, it's reading 8 ohms, which is, I mean, it's a 10 microfarad, so you're not expecting very low ESR, unless it's a low ESR one. And let's see what this is reading. Now this is reading 9.8 microfarad, and it's reading 8.9, which is more or less what this is reading at 10k. And apparently the design of this Atmel-based component tester is actually giving an approximation of the 10 kilohertz reading, which, as you can see, this seems to be pretty reliable. But obviously at 100 hertz, it just skyrockets to 25. Let me get a 10 microfarad capacitor, brand new from my stash, and see how it reads. And this is a Panasonic FC capacitor. It's not super low ESR, but I think the FR series is not available for this very low capacitance. But anyway, it's reading, yes, it's reading 8 ohms, but 100 hertz. And if I'm switching this to 10 kilohertz, it's reading 2 ohms instead of the 8 that was reading before. Is that going to be enough to cause this havoc? I doubt it. But I don't know, I guess we can try this and see if that improves anything. I doubt it again, but let's do it. And it's been many months since the last time I worked on this Focusrite. I kind of dropped the project, and the reason is it works. It only fails to work when I restart it in a hot state. So I really didn't want to risk this interface, but I didn't want to throw away the video, so I started putting it together, and I realized I didn't have an ending, and I thought, just before giving up on this interface 100%, I'd like to replace the 3.3 volts regulator. It's the only thing that kind of had a yellow flag. It was going up pretty slow, and I'm wondering whether that could be a problem. When anyways, I ordered a voltage regulator at 3.3 volts, so maybe it's an adjustable one. But anyways, exactly the same IC that is here on the board, and we are going to replace it now. Now, obviously, the 3.3 volts regulator on this board is in the worst possible position. It's in between two capacitors. So obviously, I can't really use hot air. I wouldn't use hot air anyways. I like using low melt solder and a block bus solder for the small components. So, well, let me try, and hopefully I'm not going to damage anything. Worst case scenario, I mean, we can replace these capacitors because I think I replaced them already. Let's get to it. Right, that wasn't too bad. Let's first thing first check that we have 3.3 volts. 3, 2, 1, go. Yeah, we got 3.3 volts, and well, this is working, but it's cold. Let me get my hot air station. Um, I don't think it's working because it says USB active. There's no USB attached to anything. Oh yes, the power is off. No, it's doing exactly the same. So no, that didn't solve the problem. And at this point, I hate doing it, but I'm gonna drop this project simply because the interface works 100%. I never had a single glitch, like a frozen, it stopped working, it started making noise. No, it just works. Even if you use it for 10 hours in a row, it just works. It's when you restart it. So my gut feeling says there's something wrong with the reset line, but I don't know. I think I've been investing quite some time. I'm sorry, it's disappointing when you end the video with a no fix, but this is working, so what I normally do, I just remember not to power cycle it. If I have an issue with Windows for whatever reason, I remove the USB and plug it back in. Because if I power this off, I know I have to walk away for 15 minutes. But after 15 minutes, it starts up 100% of the times. So no, I was not really optimistic about the 3.3 volts. It was the only thing that I could see that wasn't really working in my mind. I don't know, I'll have to leave it. Please, if you have suggestions, maybe this is a known fault with these interfaces, maybe someone knows exactly or has a pointer that I can look into. Bearing in mind, again, this is working, so, you know, who cares? But you know that I like fixing things. Please do let me know down below in the description. Leave a comment. What do you think about it? Am I missing something obvious? Or maybe there could be something wrong in one of these chips, one of the two CPUs, let's call it that way. Even though, again, I was warming up this area here and it was stopping every time. I don't know. I'll really have to drop this project. Unfortunately, I just didn't want to lose all the footage, which is quite a lot, obviously. Only see a small selection, and that's why I published it on the second channel. It feels like tinkering with this board without getting to a solution. But please do leave a comment. I really, really appreciate any feedback, any comment that you'd like to leave. And with these, we've reached the end of the video. Unfortunately, it's a no fix, but I hope you enjoyed it anyways. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my main channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon. The links are down below in the description. There is a free tier on Patreon, so no excuses. If you don't want to support me on Patreon, well, then maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, well, I hope you enjoyed the video. That's it for today. Thank you for watching, and I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.